Hi, I'm Thomas.
I'm Lucas.
I'm Josue.
And I'm Richie. And we're
TaxonNeuro.
Technological advancements have required the need to categorize the ever-changing landscape of artificial intelligence. From our team's research, we are proud to present the world's first automatic taxonomy construction method for artificial intelligence. AI is a tumultuous area of study, and there exist thousands of AI models, with many more being created at each day. In order to keep pace with these rapid changes, a tree or a taxonomy is required to keep track of where old models and new models fit into the evolution of this technology.
When thinking of a taxonomy, imagine how a library such as the Knowledge Center is organized. Books fall within genres, which places them within certain locations of the building. The closer two books are to each other, the more similar their topics are. This information is stored in a taxonomy for ease of reference when one needs to find a specific book or genre of books. In our approach, our library contains AI models, where researchers present their models upon which the program automatically sorts and places the model in its appropriate genre. If an existing genre does not quite match the nature of the presented model, a new genre is created. The main issue presents itself when one question is prompted, and that is, what defines a specific AI model? Our research delves into this question with deep analysis behind thousands of models to group them into logical categories that can withstand the constant reform of this ever-changing field.
Leveraging large language models such as ChatGPT, along with the newest bleeding-edge technologies, our team has developed a method for automatically inserting new AIs into their respective genres, essentially creating species or classifications of AI. We have employed a thorough semantic analysis, which allows for the chosen approach to remain automatic through the constant reform of AI.
Given the complex nature of the topic, visuals are provided to the user based upon the AI models they wish to see. These visuals break down the components of a specific model, known as an ontology, in addition to not only the relationship between the components, but the relationship to other models can be shown via the taxonomy realized. AI developers will have the ability to add their model to the tree of life, allowing for a database consisting of models and research across the globe.
This project will open new avenues for the study of AI, forming the basis for research and experimentation in the field on a global scale. Depicting areas of the field that have been heavily researched and areas that are lacking in exploration is one of the key features of our project. This can allow researchers to find resources on well-researched topics with ease. In addition, researchers can pursue aspects of AI with confidence, that their work is novel to the field with a high probability that new discoveries will be made. This prototype we have developed here at UNR has provided a proof of concept, merely requiring further robustness before deployment to the public.
TaxonNeuro.
We cannot wait to display our work
On May 2nd.
Thank you.
This is TaxonNeuro. By navigating to our import section, the user is first prompted to name and then upload files corresponding to the neural network architecture they wish to learn more about. Supporting file formats such as PI, PDF, and ONNX, our data pipeline is able to automatically extract information related to the neural network architecture. This extracted information is then used to populate an ontology. After the updated ontology is constructed, the user can either navigate to the graph section of our page or click below to view it in a new tab. Here, guided by the tabs above, the user is able to visualize neural network architectures on a per instance basis. Here, with an intuitive layout, the user is able to navigate and explore different parts of the ontology. With our search feature, the user is able to explore specific network instances or related properties. Additionally, the user has the option of selecting from any one of our predefined layouts. Navigating between tabs, the user can see different subsets of our entire ontology, visualized on a per architecture level. Again, this same ontology graph can be visualized directly from our homepage on our graph section. Navigating toward Chat with AI feature, the user is able to ask questions about the ontology. With full ontological context, our GraphRag-powered AI chat is able to both validate and answer questions related to neural network architectures in the ontology. In the case where an invalid question is asked, the user is prompted with examples of valid questions.